Hi everybody. A few people asked for some reminders about when to use what laws of exponents, so I wanted to show you how that works. Okay, let's start out with something like this, say a squared times a cubed. So if we just expand these, a squared, that's a times a, times, and then a cubed is a times a times a. And so altogether we have a to the 5th power here. And 5 is 2 plus 3. Okay, so the thing to notice here is, in these two things that we're multiplying together, these have the same base. So that's the first thing that you need to use this law of exponents. You need the same base. And then the second thing is right here, these two parts that we're combining, they have to be multiplied. So when you have two factors, two things that you're multiplying, and they have the same base, then you can add the exponents. Okay, let's look at another example of that. Say something like b to the 4th times b squared. So here we're multiplying, it's b to the 4th times b squared, and the bases are the same, both b, so we can add the exponents. B to the 4 plus 2, that's 6. Okay, let's look at another example. How about, say, c squared plus c to the 3rd. Okay, so the bases are the same, they're both c, but these are being added, not multiplied. And if they aren't being multiplied, this expansion trick that we did at the beginning, that doesn't work. So we actually can't combine these. There's nothing we can do to simplify these. We just have to leave them alone. So it's c squared plus c cubed, and there's nothing we can do with that to make it any simpler. Okay? So you can add the exponents when you have the same base and when the two parts are multiplied. Okay, let's compare this to a different situation. Something like this, x squared cubed. So here we don't have two factors that we're multiplying. We have a base to a power and then to another power. So if you expand this, if you expand the cubing on the outside, this is x squared times x squared times x squared. All right? And if you look at this expanded form, they're all multiplied and they all have the same base. So now we can actually add the exponents. So this is x to the, and then add the exponents. 2 plus 2 plus 2, that's 6. So x to the 6th. Okay. And you can see what we did here is effectively we multiplied those exponents. 2 times 3 is 6. Okay, this always works. If we have y to the 3rd to the 5th, okay, so a base to a power to another power, we can multiply those powers. So y to the 3 times 5, that's y to the 15th. Okay. One more exponent law that some people get confused about is this one. So if we have, say, a times b squared, this is a times b times a times b. But you can rearrange these to put the a's together. So it's a times a, and the b's together, b times b. And this is a squared b squared. And here it is as if this squared, this exponent, went on to each factor here. Okay? So for example, if we had x times y to the 4th power, this is x to the 4th, y to the 4th. A mistake that some people make with this law of exponents is they do this with this power when it's not multiplication inside the parentheses. So if you had, say, x plus 2 squared, okay, this is Well, so the wrong way to do this is take this 2 and put it onto each piece like this. That would give you x squared plus 2 squared. But again, this is wrong. This is not correct. Okay. At the end of Math 084, you probably talked about polynomials, and you saw that to actually calculate x plus 2 squared, what you need to do is just expand the squaring. So this is x plus 2 times x plus 2. And then you can multiply all of this out. You can use the FOIL trick, or there are a million ways to describe the trick here, but x times x is x squared. So that's this one times this one. And then x times 2 and 2 times x, that's 4x altogether. And then 2 times 2 is 4. Okay. So those are a few of the laws of exponents. The key things to remember here are for this first law of exponents, where you add the exponents, you have to have the same base and they have to be multiplied. And when you multiply the exponents, that's if you have a base to a power and then to another power. So there aren't two bases, there's only one base, but there's two exponents. All right, I hope that helps.